now we're going to move on to 18, and I want you guys to do 18 on your own. So remember, we're asking you to graph these two separate functions. So this is f of x equals the absolute value of x. Make an xy table for that one, pick some x's, find their y's, plot the points. Please pick some positive and some negative x's, okay? Then do the same thing for the second function, g. So g of x is equal to the absolute value of x minus 3. Again, I would recommend you use the same x values you did for f, and then find those y values, and then plot those points and draw that graph. And just take a look at how they're related, those two graphs. So that's all we want you to do on that one, and we'll talk about that in class because we're going into this much more in depth in section 2.5. Okay, so now we're going to learn about some more vocabulary, basically. Something called the vertical line test, okay? And what the vertical line test says, so I'm looking on the next page, the top of page 2 at number 19. The instructions say, use the vertical line test to determine whether or not the graph is a graph in which y is a function of x. The vertical line test is an easy way to tell whether the graph is in fact a graph of a function. And the way it works is, you imagine that you have a vertical line. Oh, that's a thick vertical line. I need a thinner one. Oh well. You have a vertical line that you can lay down anywhere in the plane here. Okay? And as long as that vertical line only crosses the graph once, crosses or touches once anywhere, or never, then this is a function. So 19, this is a graph of a function. 20, imagine that vertical line. I'm laying a vertical line down anywhere, anywhere, anywhere. It only crosses this line once. Therefore, 20 is a function. I'm going to skip 21 and come back to it. Let's look at 22. Imagine a vertical line. Look, here's one right here, the y-axis. This vertical line, crosses it twice. Therefore, this is not a function. This is not a function. Number 23. Now that just looks weird. But remember, don't overanalyze. The vertical line test says, imagine a vertical line, crosses it once, 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 never, none, 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 once, 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 once. Yep, this is a function. Might be kind of fun to figure out what that function is, huh? Okay. And last but not least, let's go back to number 21. Okay, if I imagine my vertical line, it doesn't touch anywhere out here, but here, it touches it everywhere at infinitely many points. Therefore, this is not a function. That's easy. Okay, you guys can rewind if you need to go over that again. Okay, now, again, we're going to focus on graphs for the rest of this section. And here's the graph of a function. Notice they did not give us an equation this time. They just said, here's the picture. Okay? But remember, this is a picture of all the possible ordered pairs. So like this point 1, 1, this is telling me when x is 1, y is 1. And they put it on there and connected the dots. They're asking me to find f of 4. Okay, so remember, it's our job to interpret. What are they really asking me? They are telling me that x is equal to 4. So I actually make a little xy table to remind myself. X is equal to 4. What's the y that goes with it? Okay, well that's easy. We come over here and we go, well, here's where x is 4. Let's go up to the graph. There's the point on the graph where x is 4. What y value is that? Now make your best guess here. I'm going to guess 1.8. When x is 4, y is 1.8. And I just read that right off the graph. That's not bad, right? Okay, let's try another one. So now let's look at, hey, that looks like the same graph, huh? That's nice. But this time they're asking me to find f of negative 3. So they're saying x is equal to negative 3. Okay, here's x negative 3. Here it is on the graph, so let's put the point there. What's the y value that goes with that? Positive 3. So I can write it like that. F of negative 3 equals positive 3. Oh, this is so easy that we don't need to do another one. Okay, let's go on to the next set of graphs. Okay, for the next three problems, they are asking us, use the graph to determine the function's domain and range. Okay, the function's domain and range. So that means, let's review what that means. The domain, remember, is the set of all x's that get used or can be used. Okay? So imagine this is a parabola and it continues to grow out forever and ever and ever. So think about what x's get used. Well, all of them. Looks like all of them are going to be used if we make this go as big as it possibly can. So the way we write that, domain, we say all real numbers, and in interval notation we use negative infinity to infinity. That's my domain. Now the range, remember the range was the set of all the y values. Now again, let's look at this. Y values. I don't use anything below -4 on y values, do I? The graph doesn't go down here. So the y values start at -4, but then they go up forever and ever and ever because it keeps getting bigger. So let's write the range here. Range, again we're going to use interval notation. -4, I need that bracket because I actually used -4 to infinity. Not so bad, right? Okay, let's try 27. Okay, this graph has, again, domain. Well, looks like it's going to be all real numbers again. Everything. I can use all x's. Negative infinity to infinity. Range, okay, this time my graph never goes above 2. 2 is the biggest y value I use. But it goes down forever because these will keep going. So, remember with interval notation, it has to go in the same order as the number line. So it should be negative infinity to positive 2, the bracket on the 2. Alright, now I'll let you guys do number 28, and I'm going to pause for a moment. Okay, the last thing we're going to do in this section is talk about intercepts. And remember, intercepts are the places where the graph crosses the x or y axis. So let's look at this intercept. This is an x-intercept because it's where it crosses the x-axis. And what I want you to realize is that the y value is always 0 at an x-intercept. The y value is always 0 at an x-intercept because we're on the axis. So this x-intercept, the ordered pair would be 2, 0. Okay? Now let's find the y-intercept. Here's our y-intercept down here. And that looks like that's on the y-axis. If you're on the y-axis, the x value is always 0. So this point is 0, -8. Piece of cake. Okay? Number 30. Let's do the x-intercepts again. I see 2 of them this time. So that's when x is -1, y is 0 is an x-intercept. When x is +1, y is 0 is an x-intercept. And the y-intercept, when x is 0, y is -1. There are my 3 intercepts for the last one. And that is it. That's section 2.1. And I'll do section 2.2 next.